Hi all, welcome to Sidza.com. Here in this video, we'll discuss about the internal energy of a system. As we all know that temperature is a measure of the average kinetic energy of the particles in a system. So high temperature actually refers to the high average kinetic energy of the particles in a system. For example, this is our system here, and these are the constituent particles of the system. The different types of motions associated with these particles, it can be a translational motion, it can be a rotational motion, or a vibrational motion. Means the particles can move from one position to another position. The particles can rotate also, and particles can have a vibrational motion to and fro. And when we measure the temperature, actually we measure these type of motions. What is the degree of these motions, the average kinetic energy of the particles. The particles have also, the constituent particles also have a potential energy, right? Due to the force of attraction between the atoms, right? Between the atoms in a molecule and between the molecules also. For example, if you got here the H2O with the water, okay? Between the hydrogen and the oxygen, there is a force of attraction, a potential energy is there, and between the different water molecules, there is some energy, right? And there are some other potential energies also associated with the particles. The sum of all the kinetic energies and the potential energies of the constituent particles in a system is what we call as an internal energy, right? So we can say here internal energy is the sum of all the different types of kinetic energies and the different types of potential energies of the constituent particles in a system, right? That's what we call as an internal energy of a system. And what are the characteristics of this internal energy? The first point here is internal energy is an extensive property, which means that it will change with the amount. It depends on the amount. If you increase the amount of the system, internal energy will, it will also increase, isn't it? So that's what we call as an extensive property. We have learned it in our previous video what an extensive property is. So therefore, internal energy, since it depends on the amount, therefore it's an extensive property. That means it will change with the amount. It is a state function also, right? A state function, we know, is something that depends on the state. A property which depends on the state, and it doesn't depend on the path by which the state was brought, the system was brought, correct? So internal energy of a system is a state function. That means it depends on the state. It doesn't depend, how you got it there, correct? It's very interesting to see here that if you have a system in the state 1 and by any process you change the state of a system, right? And here we can say in the first state it has the internal energy U1, and here it has the internal energy U2. It's not possible to measure the internal energy, the absolute value of the internal energy of a system. Means we cannot measure the absolute value of the U1 and U2, but what we can measure is the change in the internal energy. The change in internal energy, delta U, which is U2 minus U1, internal energy in the final state minus internal energy in the initial state. That is the change in internal energy. This is something that we can calculate. We can measure during the process. But we cannot measure the absolute value of the U1 and the U2. How we can measure it, we will discuss it, in our coming videos when we discuss the first law of thermodynamics. Hope you got the concept. Thanks for watching the video. Bye for now.